Right now, every AI team in the world is solving the same painful problem. You connect your LLM to Slack, then to GitHub, then to Postgres. And the moment one API changes, everything breaks. That's the hidden fragility behind most so-called AI agents. And it's exactly why Anthropic introduced something called as Model Context Protocol or MCP. If this works the way it's intended to, it could become the USB-C of AI. Let's understand what's the actual issue. Historically, connecting models to tools means building a custom integration for every single pair. For example, 5 models with 5 tools will create 25 connectors. This is the most infamous N-cross-M problem. Each connector has a different authentication flow, a different schema, different rate limits, and different failure modes. Add one new tool is more glue code adding, and adding one new model will duplicate everything. Your AI stack slowly becomes a fragile spider web, and this is why so many AI agent systems today feels brittle in production. MCP changed the shape of the graph. Instead of N cross M connection, you introduce a shared standard in the middle. You build once, everything connects through that layer. Think of it like USB-C. Before USB-C, every device needs own cable. But now, one universal port where MCP is trying to do that for all AI systems. It's an open standard that lets AI application talk to external tools through a consistent interface. Build a tool once and expose it via MCP. It can be used with any compatible environment, and that's the core idea, with simple but extremely powerful. Let's walk through a real scenario. Let example you ask, summarize the last 20 Slack messages. The LLM pauses here. It realizes I don't have the data. Now the architecture activates. There are 3 core components. First is the host. This is the environment you interact with. It could be the cloud desktop or it could be an AI powered IDE. The host manages orchestration and it decides, do I need external context? Next is the client. Inside the host sits the client. The client is the session manager. It handles tool discovery, timeouts, reconnection, and how to pass raw output into structured data. Important point here is each client maintains a one-to-one relationship with each specific server. That keeps communication very predictable and straightforward. And finally, the server. This is where the reality lies. The server sits next to your actual data. That is your database or your GitHub repo or your Slack workspace. When invoked, it translates protocol request into real actions and it runs a SQL query, fetch a thread or call an API. Then it returns structured results back to the client and then result is injected into LLM context window. Now the model can reason with live real world data, and this is the shift from static training knowledge to dynamic contextual intelligence. For this to work reliably, MCP operates across 2 layers. First, the data layer. This defines what is being sent. There are 3 message types: request, response, and notifications, with clear structure and predictable interaction. And then there is the transport layer that defines how messages move with 2 primary methods. First is STDIO, that is fast, local, and synchronous, which is perfect for local resources. And second is SSE, server sent events, that is HTTP based, asynchronous, and ideal for remote servers. This separation is very good for engineering. The semantics stay stable, the transports can evolve. All of this runs over a JSON-RPC 2.0, which simply ensures structured, reliable calls. The flow always looks like this. The LLM identifies what it needs a tool, then the client discovers that tool, the server executes the action and the structured data comes back and the LLM continues reasoning. No guessing, no hallucinated assumptions with actual context. Server exposes 3 core primitives: resources that read only data retrieval with no side effects. Second is tools, that is executable functions. This can modify state, trigger workflows and call APIs. And third is prompts, with instruction templates, predefined workflows that guide interactions. This separation makes system predictable and safer. MCP is not just only about cleaner APIs, it's changed how we design AI system. Instead of building brittle custom agent frameworks, we move towards modular ecosystem. Instead of writing glue code everywhere, we adopt shared standard. This reduces integration cost. It reduces duplication and also hallucination risk by grounding models with real context. And here is the bigger idea. If MCP gains widespread adoption, AI system won't be built as isolated apps. They will be built like plug-in ecosystem, composable, interpretable, and standardized, the same way the web evolved around HTTP. In this video, we explore the architecture and the reasoning behind MCP. In the next one, we will open the hood. We will build with minimal MCP server from scratch. And once you see how small it actually is, you will understand why this protocol might quietly reshape the AI tooling landscape. If you enjoy this deep structural breakdown, consider subscribing to SKT Neuron. This channel is where we decode what's actually happening under the hood of modern AI system. I will see you in the next one. Till then, keep learning, keep coding, and keep growing.